The other job title they used to actually have was sort of miracle maker. They actually come online, come on premise, fix your network. They'll architect your firewalls. They'll do things like build your WAF rules. They'll do the best to protect your actual application as well. And if they're really, really good, they've come to actually decide how, or even if, to try and mitigate against DDoS, because it's really, really hard. And all these guys are miracle workers. They can't do everything. So for DDoS protection, what they used to actually have to do was really, they had three main options. The first one was to over-provision capacity just in case. It's always a great option to choose. The second was to buy a lot of dedicated hardware to actually do DDoS mitigation, which they put in line with, in front of their network stacks on-premise to try and do it for you. And the third option was really to try and reroute their traffic away from the VPC into the internet and let some third-party DDoS mitigation service try and do the brunt of the work. Now, the problem with all three of these approaches essentially is they're complex, they're costly, they're more expensive, and not particularly cost-effective. So what we're trying to do on AWS is we want to try and do almost as much of the heavy lifting as humanly possible in terms of DDoS and WAF response. We want to give you a DDoS system that is, well, it's automatic. It just comes on when the attack comes in. It just works and is in line with all of your systems and all of your networking as well. So there's nothing specific you have to do to actually try and configure these things. So goes the theory. So I'm going to try and cover 5 things quickly. Now, the first one is really the types of threats that you're going to see out there in the land of DDoS and WAF. The second is to talk briefly about the kinds of things you can actually do at the DDoS level, sort of layer 3 and layer 4, using AWS Shield. We're going to look at how to protect against web layer attacks using AWS WAF. We're going to briefly talk about how to architect your systems, hopefully, more efficiently and more effectively to take advantage of the DDoS facilities that we offer. And the last one is going into a bit of compliance management to do with our new service, the AWS Managed Firewall that got released last month. And just for absolute insanity, we're going to try 3 demos. And on the Wi-Fi we're having today, this could be interesting. So please, please hope the demo gods are smiling, because this could be quite a short presentation if it isn't. So we'll start off with this one. So before we get into how we actually mitigate against all the different attacks that we see at layers 3, 4, and 7, we thought we'd go into a little bit of background behind what sort of attacks you're actually going to see. I think it's important just to get a quick review so we have sort of common language, common understanding of what we're doing. So this falls into 3 distinct categories. Now, the first one for DDoS is really mostly at layer 3 and layer 4, so the network and transport layers. Sometimes it happens at layer 7. These attacks are really quite simple. They're trying to basically exhaust the resources in your application or in your network stack. They want to soak up as much CPU as possible, take up all the bandwidth they can away from your paying customers, and if they possibly can, just throw as many high-rate transactions to you as possible to knock you offline. They're not particularly complicated, but unfortunately, they are extremely effective. The next one really is at the application layer. So at layer 7, these take advantage of vulnerabilities actually in your application stack. So it may be problems that you've got in your application that you've put there yourself, but if you do good secure coding techniques, that won't happen. But it could be in the underlying firmware that you have. It could be in struts. It could be in a third-party application such as MySQL. And not to pick on those guys or things like WordPress, these people, along with other software vendors, they issue security patches month after month after month because the attack vectors always change. They have to keep updating their application stacks to protect yourselves against these attack vectors, and you have to, in return, patch your systems. And that's what the hackers are looking for unpatched systems that are out there they can just take advantage of. And that's what they try and do. And the last one is bad bots. Bad bots are a strange category. These are the crawlers, the scanners, the probes. The systems going around your websites just looking for information they can basically steal. So they're looking for pricing information. They might be looking for premium content. It could be sort of movies. It could be books. It could just be image tiles for a mapping system that you happen to have that you've paid lots of money for. They just want to steal anything that they can find by trawling your site and taking it away. Now, the sort of philosophy of our mitigations is on the things on the left-hand side for DDoS, essentially layer 3 and layer 4. We want you to try and use services like CloudFront, Root53, the Elastic Load Balancing System to try and mitigate the risk as close to the source of that traffic as possible, as close to the client as we can actually get. And when it comes to layer 7, though, it is slightly different. We actually have to know an awful lot about your application to mitigate at the layer 7 effectively, automatically. So there it comes more of a shared responsibility model, and that we provide you with WAF tools and flexibility to protect your systems. But in the end, we have to work with you to actually get those WAF rules written because we cannot do it for you. Well, not completely anyway. So DDoS, this is a classic diagram. The very first D, as most of you are probably aware, I hope, is distributed. So there are countless bots or compromised systems around the globe that are trying their best to attack your system and basically take it offline. Now, don't forget, compromised system these days is not just some server sat in their server room somewhere on a data center. It includes your fridge, your internet-connected toaster, and perhaps even your baby cam and webcams in the house. These are all now eminently hackable because they just contain small Linux cores. They're not that well protected. Most people don't change the standard passwords that come with these things. It's probably always admin on the router you just bought from eBay. These things are quite easy to exploit, and people do. And why wouldn't they? Now, the goal is really to overrun the resources on your system, to just try and knock you offline. So high volume requests will take out your bandwidth, take out your backend resources. And if they can actually stop legitimate users getting through, that's their mission. It's not to actually break the system. It's not really just to crash it. It's just to make it so that no one can get to it. And if you happen to be an e-commerce platform on Black Friday, if someone can't get to you, that's pretty much your year ruined. Now, what we've seen in the field, if you talk to the DDoS team out in Seattle, is about 65% thereabouts of all attacks we see globally are basically these volumetric attacks. They are really simple to launch. They're really simple to do, and actually not that hard to mitigate against, as long as you have some tools in place. And about 17–18% of those attacks are ones that are just trying to sap the actual resources at your back end. So let's say using things like SYN floods, which try to actually exhaust the state on your back-end systems. They don't get as far as your back-ends. It would just be your front-end web servers trying to open TCP connections, and they'll do the best to exhaust you at that point so you can't actually accept a real connection. Very nasty, but very easy to mitigate against. So the on-premise mitigation approach, it was really to make sure your network can actually scale out to support all the bandwidth that can come into your data centers, and make sure you can apply DDoS to all of that traffic that's actually coming in, and try and do all the mitigation on site. This actually has one major benefit in that you have absolute visibility and absolute control of what's going on in terms of WAF and DDoS. You bought the kit, you deployed the kit, you installed, you configured, you know exactly what's going on, and that's actually a good thing. The problem with it, the kit's not cheap. To actually buy these large DDoS mitigation devices or spend lots of money on WAF services is expensive. And not only is it expensive, it's quite hard to manage and maintain. And the resources you need to maintain that workload, again, they cost money, unfortunately. Now, sometimes more recently, people have been looking at more of a cloud mitigation approach. So rather than have all the traffic go through them on-premise, you try to subscribe to a third-party service in the cloud that does things like managed WAF or managed DDoS defense. The traffic, first of all, goes there via DNS, and hopefully that third-party system you subscribe to will scale out and do all the DDoS mitigations or the WAF mitigations, and only pass back to you traffic that is good. All the traffic that is bad gets black-holed. So that's really good. You can mitigate large attacks off-premise that you probably couldn't handle on-premise, so that's actually a good thing. And you can do it without much in terms of upfront investment. You're not buying kit, you're not buying people to manage and maintain it, to feed and water it. It's just a service you can buy online with a click of a button. That's actually really powerful. But it is just a click of a button. You tend to get a black box solution. You tend to get a solution that you can't really get much visibility into. You can't really see what's going on. To get alerts when things happen is quite hard. You just have to be assured by the vendor that we fixed that problem or we mitigated that attack. It's quite hard to actually see it. Also, these other SaaS providers, the location of their systems may not be well placed between your end users and your data centers. It's going to be wherever they happen to have decided to put their SaaS solutions. So it could actually add latency to the request from your customers just to get through the WAF solution that you've built or the SaaS solution. It also introduces other additional points of failure that are actually outside of your control. So when your cloud-based WAF goes down, or your third-party WAF goes down, who can you actually call to fix it? Well, it's not in your environment, you can't really see it. All you know is it's not working. You're not getting the response from it that you think you need. So you're into the realms of SLAs, which are never a good place to base your security policy on. So what we try and do on AWS, we try and make this cloud native. We want it to be automatic. We want it to be always on. We want it to be inline and give you protection for your resources for all the apps that you have on AWS. Now, the best thing to do for this is to take advantage of everything that we actually have, to take advantage of all the resources we have in all the regions we have in the world, so 18 major ones, one minor one, all the 116 different edge locations and regional caches that we have, and use them to try and mitigate the attacks before it even gets away from the user's location, before it gets near to the actual AWS region. It's got to be simple, or you won't use it. It's got to be flexible, or you won't use it. It's got to be cost-effective, again, otherwise you won't use it. And unless you can see what's going on behind the scenes, unless you can see these attacks happening, unless you can see the metrics for these attacks, it's less useful than it might be. So network engineers will cry out, why do we actually have to do this? We're doing this really well right now on-premise. We're not getting taken offline much, as we think. So why should we do it? Well, the problem is really scale. It's an ever-changing threat landscape out there. Things keep getting added to what these attackers are trying to achieve. New vulnerabilities get introduced every day in the third-party software you're currently using, so the attacks never actually go away. They're not going anywhere. They're going to keep coming day after day. If you mitigate today, they will change the attack tomorrow. So you've got to keep moving, keep changing. And to actually mitigate against all of this stuff using your security team, well, that's great, but that will be a manual process. And as you add more and more attack defenses, mitigations to your services, that means your team will become a bottleneck. And that can be solved, obviously, by increasing the size of that team, which increases the cost you've got of your overall system, because you're now paying for more people to basically do the same job that you could actually automate away. So the size of your team, or the size your team has to be to mitigate this, just makes it just not cost-effective to do it like that in the cloud. And repeatability is also key. You really want to know from a compliance point of view that your mitigation has been run, and it's been run successfully, and it's been run the same way on every WAF you've got and every CDN distribution you have across the entire globe. You want to know how often was this config changed by the user. You want to know basically how many times this remediation has been run. You want to know it's been run the same way every single time. If you're just following a runbook diligently and hopefully very, very accurately, that's not the same as automation. That's just waiting for that one error to happen in that manual process where someone misses a step out or misinterprets some data that they see, and the attack gets through, and your mitigations haven't gone on properly. So by automating this whole thing, it's actually really quite key, and it's the only way we really think you can do this properly at scale. Now, some of you may have seen this variation of this slide today elsewhere or at other AWS summits, so it's really trying to say where the information associates come from a security perspective. Now, the top line shows Macy, CloudTrail, and GuardDuty, so they're the ones that are looking at checking your S3 buckets for data exfiltration, or who's moving things around. You're checking CloudTrail for API calls, who's doing things they shouldn't do. And then you have GuardDuty, which is now looking at your network traffic flows, ingress and egress to and from your network, to seeing what looks suspicious and trying to point out when bad actors are at play. Now, them, along with things like on-instance logs, Lambda logs, deep flow logs, they will all in the end try and generate a CloudWatch event or a CloudWatch alarm. Once you have these things, you have SNS notifications at your disposal. Once you've got that, you have Lambda functions, and you basically can mitigate anything you see in any way you see fit, which is really good. So WAF and Shield, they fit in at the bottom. So the whole point of them is they can actually generate sort of CloudWatch alarms, and once you have those CloudWatch alarms generated, you can do what you like in terms of mitigation. Of course, with DDoS, we will mitigate automatically anyway. But what we will do is, with Shield Advanced, we'll send you an actual SNS notification so you can go and do other things as well. So it'll give you much more visibility into your estate because you can see these alarms, you can see these metrics, you can see what's going on. So when I came on stage, I did say that we can automatically protect against quite a large number of the common DDoS attacks. And so I'm going to talk about this in context with AWS Shield, and then we're going to try and do a demonstration of a live attack. I think we're going to pick a 15 gig UDP flood against AWS, just because it's fun to attack your employer without actually being sacked. So we'll do that as well. But I'm going to go through it quite quickly, along with 2 other demos. So if you've got questions about how the demo is set up in more detail, please just grab me at the end. We'll try and run through this as quickly as we can in terms of demos. So Shield, there's 2 flavors of Shield, Shield Standard and Shield Advanced. So Shield Standard is available to all AWS customers at no additional cost, and you cannot turn it off. Because if we turn it off, well, there's no reason for us to turn it off. Why would you turn off that sort of protection at CloudFront on the load balancers or on Route 53? It makes no sense whatsoever for you or for us. And although this was launched at reInvent at the end of 2016, it has been there for some time. We just didn't really talk about it very much. And it was only when we sort of announced Shield Advanced at the same time that people realized what Shield Standard actually gave them. Shield Advanced is a bit more. It's a paid-for service on top of your standard bills. It gives you extra protection against certain things. It gives you extra mitigation, extra features, extra benefits. And we'll talk about them in detail in a sec. So Standard is really good. It gives you automatic defense against basically the most common network and transport layer DDoS attacks on any DDoS resource in any region. We think we can block about 96% of all DDoS attacks coming through Shield Standard just like that if you use CloudFront and Route 53. That's what you get by doing nothing and paying for nothing and just using CloudFront. That's what comes out of the box. But if you use CloudFront and Route 53 in detail, you can actually protect more and more and more, and we think we can get all the known standard DDoS attacks against the platform. Really quite simple. If you want to do layer 7 defenses against the application there and against WAFs, you have to use AWS WAF, which you have to pay for separately, but it's all sort of controlled through the sort of Shield and WAF console. Advanced gives you many more protections, and as many of you actually know, the price for this is about $3,000 per month across all of your accounts. It might seem quite a lot, but if you're a large enterprise with 100+ accounts, $3,000 divided by 100 is not a lot. And what you actually get, is it worth it? Well, The difference you actually see, the first difference you see is visibility. Don't take our word for it that nothing's attacking your account. Go and have a look at the CloudWatch metrics. Look at the CloudWatch alarms. See if the attacks are actually in progress. And more to the point, see if the attacks aren't in progress. You can get that nice, comfy feeling knowing nothing is attacking you. And when the alarms go off or you see things come in, you realize this is happening. It's a UDP flood, it's a SYN flood or something. It's a UDP reflection. Doesn't matter what it is. It's all listed nicely in the Shield Advanced console. And because it generates a CloudWatch metric, CloudWatch alarm, you can trigger a notification to go to your SOC. You can raise tickets in your Zendesk system. You can call Lambda functions to go and wake other people up via PagerDuty. Do what you like. But you get the notification, you get the visibility, and you can take reactions to it as you see fit. Now, detection. By default, against Shield Standard, we monitor all traffic essentially coming into our regions. We've got a sort of known baseline, and so we look for deviations from that baseline. So when we sort of see high entropy or signal deviations from that baseline, we think DDoS is happening. So we deploy the mitigations as we see fit, and we stop the attack. That's great. Shield Advanced, we changed that slightly in that we actually monitor traffic and generate baselines for your application stack. So we start deploying mitigations that are much more suited towards your individual application, and we start declaring DDoS for you when we wouldn't for someone else, and vice versa. So things that would be normally a DDoS attack might be absolutely normal for your application, in which case we'll let it slide because we're now monitoring your application for what it needs, not against the general needs of the rest of the AWS population. So cost. So if you have any sort of scaling actions that happen and through a DDoS attack, like your load balancer scales up, so you have more instances in place, you get more LTUs for your ALBs, you get more requests from DNS from Route 53, you get more requests from CloudFront, all those costs get refunded. Simple as that. You just give the money back via support. It's not a problem. And also with WAF, there's actually no additional cost for WAF if you have Shield Advanced. So if you have 100 accounts and you have an ALB in all those accounts or CloudFront distributions, put a WAF everywhere because it doesn't cost anything. You may as well put it there, fill the boots, put WAF rows across the whole estate, and just use them because they work really well. And we'll show you at the end of this a new system we have that actually helps you deploy WAF rows globally, which does make life slightly easier. The last thing you get is DRT access, the DDoS response team. These guys in Seattle, they will basically get on a call with you if you have a ticket and support to help design and build your WAF roles. And they'll basically give you all the advice that they've got through their years and years of knowledge of basically hacking and stopping hacking attacks to help you design your roles. You can also talk to them about custom mitigations for your application stack. If you've got really bizarre traffic patterns, then just let them know, and they can help shape a good mitigation for you. So basically call them and use them. They're really useful. They have other benefits too, which we'll get to in a bit. But I think it's like enterprise support. Customers who have enterprise support don't tend to raise tickets for development assistance with support. Please do. You've paid for it. Same with Shield Advanced. You've paid for this. The DRT team are there. Call them. They're happy to help and talk to you and actually help you protect your systems. So where do we actually protect you and how? The first place we want to protect you is at the internet layer. We want to protect your services and the VPCs in Ireland or London or Frankfurt, wherever you happen to be, before the traffic gets to you. If you can mitigate in the internet somewhere, that's all the better. So this is basically for large-scale attacks. This is where you employ large-scale traffic engineering things. So we've got some good mitigations for CloudFront that we can do. And the reason we can do it with CloudFront and basically stop things getting towards the region is we control the CNAME for the CloudFront endpoint, which is good. So we know what IP address it happens to be. We control the BGP announcements and route announcements to get to your endpoint because we control the BGP as well. So if we change both of those things in concert, we can basically take the traffic going towards your endpoint and just gently shuffle it away sideways into a black hole, and you'll never see it again. But more to the point, it will never hit your endpoints, which is kind of the good point of this. If it doesn't hit you, it can't affect you. So all this happens at that point of the network. Next one down is at the border network, once you get to the edge of the AWS regions. This is where things like SYN floods, UDP floods, that kind of thing generally gets picked off. Anything that's traffic sourced from suspicious networks or from geos you don't normally use. You may be an e-commerce website in London getting lots of traffic suddenly from Southeast Asia, which you wouldn't normally expect. So this is where this kind of thing can get picked up. So the mitigation techniques behind this is based on a system called Blackwatch internally. These things are actually deployed within our border networks across all the regions. So as we scale out our regions, as we scale out our availability zones, as we scale out all the traffic we have for our customers, Blackwatch basically scales with it so that we can try and get all the traffic in line going through a Blackwatch device and get all these mitigations in place in line with nothing else getting in the way between the outside world and your VPC. CloudFront does other things for these particular attacks, so SSL attacks, slow LoRa's, things like malform HTTP. CloudFront just eats it, spits it out, and you'll never see it again. It just doesn't get through CloudFront, which is a good thing to see. Web layer, this is where you get into the level 7 WAF rows that you've written or you've got the DR team to write for you or help write with you. So these come into play here at this point. Unfortunately, there's one more click on this slide. because these vulnerabilities keep changing every day, every week. You might find something that's safe today is not safe tomorrow, and you start getting more zero-day attacks. These may well get through your WAF because you haven't got a rule for it, because no one's seen it before. If it does get through, because you're a Shield Advanced customer, basically you can give the DDoS team roles and permissions into your accounts to go in at the point of an attack and fix your WAFs globally. So they'll just go and do it. You'll also get alerts and alarms. You'll get woken up. They'll then call your engineers and tell them what they've done so you can put it into your build pipelines, etc. But if these things get through our defenses, the DRT team are on call. They will log into your WAF if you give them permission. I stress that. They won't do it unless you do give them permission, and they'll just fix it. So before your engineers hopefully even get as far as their inbox, the DRT team have gotten online and that actually fixed the zero-day issue before it's had much impact on your application stack. DRT are great. Please use them. So I'm going to demo now in Shield Advanced. We're going to actually do a large UDP flood against AWS, because why not? And I'm going to quickly show you how the monitoring and alerting is actually set up. So I shall just mess around with the monitor control for a sec. So bear with me. OK, so let's look at WAF and Shield. First thing that's worth seeing once you get into the WAF and Shield console, especially when you have Shield Advanced, is to go and have a look at what's going on in the world today, what's attacking us. And once the Wi-Fi actually wakes up, this will show you an actual map of the world and give you a summary of the attacks that have been coming in basically in the last day. Well, that's actually not too bad. So 164 gigabit per second is the biggest attack we've had today, 56,000 requests per second. That's not actually that bad. And the map shows you the concentration of the attacks. Now, it's fairly understandable the biggest attacks are in US East 1, Virginia, in Dublin, in the West Coast of Oregon, and in Tokyo, because they're sort of the biggest, oldest regions. It's not surprising that's where the biggest attacks actually go. But if you look through this for, say, the last 2 weeks, 322 gigabit attack, that must have been fun to mitigate against. And 250,000 requests per second going into one particular system as an attack, that's not much fun. But as far as we're concerned, that's just normal. So this is what we're soaking up, essentially, every day, every week, across the entire year, across the global estate. And we're happy to do it. And this is where Shield and Shield Advanced actually comes in and lets you get more things along those lines. So let's show you what we're doing with Shield Advanced. First thing you have to do with it is tell it what resources you want to actually protect. It's because we don't want to make any assumptions on your behalf. So if you want to protect 6 CloudFront distributions and not 2 more, or just your ALBs in production VPCs, not your non-production VPCs, that's actually down to you to configure it. But once you have set it up, you just tell it, I want to protect this application load balancer, and let's just, hopefully, nothing will actually get through. Bear with me, I'll just bring up a few other screens. Now, if you go to CloudWatch, what you can actually do with the metrics is there are an awful lot of metrics that you can look at for, there we have, WAF and DDoS. So what you can do against CloudWatch, you can set an alarm against every single possible attack vector that we look at, which there are 16, against this one particular ALB, if you want to. Or if you're feeling particularly lazy, like I was today, just say anything that hits this load balancer, that will do for me. That's a DDoS attack. Please let me know what's going on. And that was all I was particularly bothered about. So we have a dashboard in place that basically says for DDoS what's happening. That was a UDP attack that happened a while ago, but right now there's nothing actually going on. There's no DDoS traffic hitting our system, 0 bits per second. That's always nice to see. Nothing's going on. Everything's a bit quiet on my system. But what we set up that metric for to do is it will trigger an SNS topic called DDoS detected if anything actually gets found. And what that's going to do is, if you can see it here, you possibly can't. Yeah, that's unfortunate. That's actually a link into PagerDuty. So we could actually wake up your on-call engineer on his phone, which we'll actually do shortly. So I have my phone here. It's all set up with PagerDuty. So hopefully by the time I set my attack off and it hits Shield and it gets mitigated, hopefully, I've given it a minute's delay before the alarm goes off, but hopefully PagerDuty will kick in and wake someone up. But by that time, it should all be done, dusted, and mitigated against. Okay, so I'll just take that away again because to actually show you the DDoS attack we are using, it's probably not good for my career prospects, so I shall hide that screen for you guys, but it will just take a minute to get it in there. That's 1523. We'll make it last for 5 minutes. I'll make it 15 gig. And it's launched. And true to form, the credentials in my AWS console have expired. Like any temporary credentials that you have on site, this happens to us as well in mid-demo. So let's log back in again. So instantly, it's basically said there's an attack going on. It's against one particular load balancer. If you look at the incident, it said it's a UDP attack. We spotted it already. It's ongoing, and it's been mitigated against now. So the second that basically hit the Blackwatch fleet at the border network, the doors came down, clamped on it really quickly, and the attack was basically killed off at that point in time. So the actual ALBs itself are not really seeing much of this traffic. It's not hitting any of the back-end instances. Nothing's really aware of what's going on, but it's been caught, it's been mitigated against, and everything's basically going away. So if you look at what CloudWatch basically says, change the metrics, all right, to 1 minute. It should basically say we've got a 15 gigabit per second attack coming in right now, and that's what we're seeing, and that's what's been mitigated against. Now, the alarm hasn't gone off yet because I've given it a minute's grace, so it might take a few more seconds of that to actually kick in. But this will keep going on for 5 minutes until it basically gets bored, and the attack I set up will basically stop. And that will keep going. That was it coming off. I was hoping it was louder than that on the system, but never mind, that was PagerDuty actually kicking in. So PagerDuty has actually now gone off. So if I go and just log into that particular PagerDuty site, it should say there's a notification in place. There is, DDoS has been detected. What we're going to do about it? Well, quite simply, I don't care because AWS fixed it. So resolve the ticket, go back to bed. So that's my on-call engineer. He's now happy. He's now fixed it. But go back to the Shield console, and it's still saying it's in progress. But there is nothing to do. The attack is going on. It's still being mitigated. There's no point in the engineer looking at anything else. The job is done. So, of course, you could decide not to issue a PagerDuty call. You could decide if it's something that's actually been mitigated already, you could trigger a Lambda function to actually check that and not wake up your engineers. They would prefer that, probably. But you could just wake them up, make them feel like they're earning their on-call money. That's always fun, too. OK, so that was that. Really simple to actually do. Shield will just tell you what's going on, what the attack is coming in. You go through CloudWatch, look at the metrics, look how big that attack actually is. That can trigger anything via SNS you see fit. So it could be a PagerDuty. You could launch some stuff into a Slack channel if you wanted to. I've done that before as well. You could just raise a ticket in Zendesk or Jira, have that notify someone instead, put something in service now to trigger another on-premise notification chain. Doesn't really matter. You've got total control, so you can use it. So that's Shield Advanced. So go on to WAF quickly, because I'm running out of time slightly. So if you look at WAF, what we actually want to try and do is we like good users and we like good bots. So we want to do anything we can in our power to let those people and systems actually connect to our web server and connect to our backend and do what they want to do, which is hopefully buy some stuff off your sites if you're e-commerce, or just get more information about your corporation and actually use your services in the future. That's great. Unfortunately, we have bad guys. Bad guys hate you. They want to wipe you off the face of the earth by trying to hack your systems, block access to your systems, etc. So first and foremost, what they're trying to do is get to attack a bunch of vulnerabilities that are commonly called the OWASP top 10. They're basically the top 10 web-based vulnerabilities that exist. The list updates every year. I've just noticed in the last 5 or 6 years, the top 10 never actually changes. It's just the priority of them between 1 and 10 changes. It's the same stuff that comes in day after day, year after year, and just never goes away. Because these vulnerabilities keep getting reintroduced because they're great. They're really easy to attack. So they just don't change. So the guys who are releasing the software keep releasing more bugs, keep releasing more vulnerabilities, more zero-day attacks. And the hacker's job is there for life. So what we're trying to do is things like SQL injection, cross-site scripting, that kind of stuff. So the WAF can do that natively. It can do all the OS top 10 really out of the box. Just by writing simple rules, you can actually block all of those things which you want to do. And the bad bots are slightly harder, mainly because they look just like good bots. The only thing they're doing differently is they're scraping content that you probably don't want them to scrape. So we have got examples in our GitLabs account for AWS that show you how to get mitigations in place using Lambda to actually spot bad bots a bit more programmatically, shall we say. From that, you can then do things like automatically blacklist those bots' IP addresses, so their attack will then just drift away because they suddenly can't connect to you. But detecting good bots and bad bots can be actually quite difficult to do, but with WAF and some Lambda functions, you can do it. So why do people like the AWS WAF compared to other solutions? It's not really just about the detection, it's also about the mitigations. So when you have a mitigation to actually deploy, we want that mitigation to get deployed now, in a minute, maybe 5 minutes. An hour is too long, certainly not days or a several-day SLA that some external providers might actually have you do. What you want to do is when you define the WAF rule, when you hit the submit button, when you attach it to an actual deployed ACL, it will be global across all your load balancers and across all your CloudFront distributions in 55 seconds. And 55 seconds is actually the worst case. It should be more like 15 or 20 seconds to go global. But that's all it takes for the zero-day attack to get wiped out across, or virtually patched across your entire global estate, which is pretty fast. The second one really is a flexible rule language. We always appreciate feedback from customers on this because it could always be more flexible. So if you use WAF now and you think it could be better, tell your account team to put in feature requests for changes because the team will listen and will hopefully get some of those changes into next releases. So please get feedback where you think it could be more flexible because we do want to hear. But we'd like you to actually inspect most parts of the messages. So you can look at the header, you can look at chunks of the content, you can look at the URI, and based on that, you can decide whether or not a DDoS attack is actually present. So you can do all these things at that level. Automation is key, as we said earlier, to do this sort of security level at scale. Without automation, it's not going to work. You're going to basically burn people out or have to hire more and more people, get more and more things on call at night. Unless it's fully automated, it's not going to work. And one thing people are asking for a long time, which we released in this at reInvent last year and expanded it again in February, was managed protections. So a lot of you actually have managed services, say people like Fortinet or F5 for their managed services for WAF. And rather than adopt our WAF and try and replicate all of that stuff, what we've done instead is we now allow those providers in the marketplace to provide you a set of their WAF rule groups, which you can subscribe to and attach to your load balancers, attach to your CloudFormation templates. So if you like F5 for their CV protection, or if you like, say, Trend Micro for their protection against WordPress and things like that, you can just subscribe to them on the marketplace and attach it to your web ACLs inside WAF and just say, I want these, please. And they can become your global standard protections that you have now. So rather than rebuild all the F5 rules that you already have, using the expertise in-house you haven't got because you're using the F5 SaaS service, of course, you can just migrate them essentially into us by using their managed service. And there's no long-term contracts. It's basically paid by the month according to the marketplace that we have for these. And as sort of Trend and Imperva and Co actually update the roles behind the scenes, as they support more CVEs, they update the role set, and it gets pushed out to all your WAFs that have the subscription in place. So they're actually managing the role set behind the scenes as well. So as sort of F5 find more zero-day attacks meeting the servers that you subscribe to, such as the CVE subscription, they'll update it, and you will get it. So in that sense, if you haven't got experience at writing WAF rules, but you like these providers anyway, that's now something you can just deploy across the globe. Any security engineers know what that CVE actually is? It was out last year, spring of last year. It's a really fun one for struts. It basically means if you put a sort of command imperative in the request, in one of the headers, such as content type or content length, you could actually inject any opportunistic code you liked to run on that system. And that system could do lots of interesting things. It could just leak information, leak data, leak PII customer records. In one global corporate case, tens of millions of PII records for customer accounts. And it was a really, really simplistic attack that took a lot of people unawares. But the problem with actually fixing this sort of bug is most of the corporations that saw this, they got notifications from the CVE repositories that these things happened. Great. They actually instructed their IT teams to fix it all, which was good. The IT teams had methods to actually search the estate to look for the vulnerable systems, which was great. They didn't actually find them all. Because the systems that were not deployed as per corporate standards, they were not behind the right firewalls, perhaps just in PCs under people's desks, running local systems, etc. So they didn't actually patch everything. So the attacks happened. So why would you virtually patch? Yes, partly for that reason. You can't always find the things to patch. You can't wait for a 3 months deployment window to say, well, we can't fix this system, it's production. We've got to wait for the scheduled maintenance window in 6 weeks' time. That's 6 weeks for an attack. That's not going to work. So by virtually patching, you can basically take away the problem in the very, very short term, fix it at the WAF layer, and then you can run behind the scenes and patch and update all the software. And please don't trust your WAF role to protect you from vulnerabilities in that sense. Update the software as well as soon as you can. But by doing the virtual patching on top, you can really quickly protect yourself from that vulnerability going forward. Or there goes the plan. So let's show you how quick this is actually to do. Back on this account, let's go back in there again. So back into WAF and Shield. So what this one really boils down to is a regular expression. Regex is wonderful, fixes lots of different problems in the universe, and this is just another great example. So I've only got one ALB in this account, happens to be in Virginia. So I'm going to create a regex. So I'm going to call it struts fix. As you can see, I've done this before. String match, we're going to search on a header. We're going to look on, oops, if I could actually type content length, yeah, that works. We're going to do contains a particular string that's converted to lowercase because you never can tell what people actually do. We will put in what we're looking for. And that is now a WAF filter. But it's not applied anywhere. So what we want to do is create a rule that just has that in. It's really simple. So a rule is when something matches this filter in the string match condition, so we now have a rule that has that in. What we want to actually do is go to the web ACL we have, which is what we've currently applied to our load balancer. It's doing something else at the minute, which we'll get to in the next demo. And what we want to do is say, right, we want to edit the web ACL we've got to add this next rule. Done. So within 20 seconds, hopefully globally, 55 seconds worse, I just protected my entire estate from that strut CVE. So that took 2.5 minutes. That's all it takes. So now you can spend the next 3 months actually patching your software and patching your systems, and then probably take that rule away at some point in the future because you don't require it anymore. But that's it. That's virtual patching in literally 200 seconds. Back to this because we're almost done. So a little bit on architecting for this sort of stuff, which I'll go quickly because we're down to 5 minutes. So if you're looking on EC2 instances, inside of VPC, there's not much you can actually do apart from try and outscale the attacker, which is not great. It's not the best solution. If you're inside of VPC, though, the other things you have at your disposal is you have a reduced surface attack area because VPC protects most of your resources by making them all private. And you also have some interesting things at the layer 3 level because there's certain attacks that can happen in the VPC because you can't spoof the IPs. So all that protection comes on top, of course, as well. Put on layer, ELBs as well, then you have sort of layer 4, 6, and 7, and also protection from slow loris. That comes in place as well, and that's really good. The only problem with this approach is this is all inside your VPC. This is where this stuff's all getting mitigated at this point in time. So it's hitting your resources. It's causing ELBs to scale. It's causing potentially server fleets to scale up as well. So what we'd rather you did was use CloudFront and use Route 53, use API Gateway, and use WAF. Because that then does this from a geographic isolation point of view, because we're now trying to mitigate this stuff away from your VPC, actually away from your resources. And so to build this up is fairly easy. You just do your usual server system with an ALB in front of it, and just use Route 53, WAF and CloudFront, or API Gateway and CloudFront in front of everything else. And you will get the ability to protect pretty much against everything we can protect automatically. And if you can't do this automatically, we could do a WAF rule instead at the outside layer, or a WAF on the ALB, and protect it then from all the user traffic actually coming in. So this is where we try and recommend users do as a basic architecture. I mean, it's not rocket science. It's just an ALB with edge services in front. But if you do that, you get almost everything we can actually do out of the box for free with Shield Standard. And pay with Shield Advanced, you get the extra stuff as well. So quickly mention the managed firewalls. We've just got enough time for this. So the Firewall Manager is actually one of those things that's really, really good fun. It got released last month at the San Francisco Summit, and the idea behind this is you can now create a set of firewall rules that you want to be your global standard across your entire system. And once you put them in place, they will always get applied to your ALBs and CloudFront distributions. If someone takes them off, you'll get alarms, you'll be told about it, so you can automatically put them back on again. If somebody takes it off again, you can use a lambda function to take away the I am right, so they can't do it ever again, or even do the job ever again. But you've got that complete control. There's two things it requires up front. One of the organizations. So this only works if you have organizations turned on. And you declare one of your accounts as your firewall master. And your accounts must have config turned on as well, or it doesn't work. So I shall jump straight to the demo. And the few slides I missed out, not to worry, you'll get that essentially as part of the release of the slides when it actually happens later. So we're assuming we've got a two-organization account. We're going to drag into the fold a third account, which is part of our shadow IT that everyone actually has and knows and loves. And we're going to drag it into our estate, and we're going to basically try and see what firewall rules we can fix automatically. So I've invited my third account to join my organization because we discovered it hiding and lurking in the darkness of the organization. If anyone's used organizations, you roughly know what it does. It tries to basically create business units and OUs for your whole organization inside AWS. You invite everyone together to share the joys of being inside a single organization. So you can also share like organizational control policies. You can share lots of other things. Managed firewall is one of the first big things that it's going to let you share. So hopefully it's going to join the organization. Yes, welcome. You're now in our organization. So if we go to my security account, which has been defined as a firewall master, well, that was faster. Go back to Shield. Go down to the bottom for security policies. And this will scan the account and tell you what accounts it has found that are in compliance and which are not in compliance. Now, already it's found the two accounts that's been protected. It's the root account of the organization and this account. And it's already found that the third account we've just added in by organizations is not in compliance. And eventually, on screen, it will actually show you that it's not in compliance. There we go. OK, so what this will actually do over the course of a few minutes, which I don't think we actually have, but I'll leave it running anyway to look at afterwards, it will spot that thing is actually non-compliant. It will then apply the WAF rule that we've already defined as our standard rule and stick it on top. And that will become compliant in about 3 or 4 minutes, which I don't think we actually have. So that's what the Firewall Manager is actually meant to do. You sit in one place, define your firewall rules that are going to be applied globally, you create your ACLs, and then you just point it at the accounts that you want to actually protect. And as those accounts come out of compliance, even when they're added as a brand new account that you've never seen before, just been dragged into your organization, it will patch the WAFs instantly across all of CloudFront, all of the ALBs, and get them into compliance. And if the developers in those teams try to break that compliance, you get notifications and alerts, and it will just get reapplied. The last thing to mention before we just wrap up, one thing that's worth saying is it's not all doom and gloom for the developers. Because if they have their ACL, which is this one, the global WAF rule, you may have seen this one earlier, the actual global WAF rule is this basic rule group which enforces corporate IP ranges across all your ALBs. So you can only get to the ALB from the corporate IP spaces. Development teams can add their own rules on top as well. So if they have other application requirements, from a WAF point of view, they can layer it on top in a hierarchical fashion on top of the main WAF rule. If they touch rule number 1, they'll be found out. If they add rules 2 through 10, they can knock themselves out. It's absolutely fine. OK, so the wrap-up slide really is closing thoughts is these things are not going to go away. You think you're absolutely safe today, and you probably are. Tomorrow, you might not be when you do the next software rollout, because these things just keep breaking. Shield tries to make things easier for you guys by giving you notifications and alerts and visibility into the actual attacks and what's going on, and trying to automatically mitigate everything you possibly can. WAF is not quite a black box because you're defining the rules. Yes, DRT guys can help you, but the whole point is they're your rules, you've got the visibility, you control, you add, you edit, you delete to your heart's content. And we try and simplify the response process basically by saying, once you've got SNS and Lambda in play, you can do anything you like. You can tie it into any process you actually like. And that's me, just a minute or two over, unfortunately. So thank you much for attending. I hope you all learned something. Thanks for coming.